Okay, so let's look at the introduction of the timer. Okay, in micro P, okay, we use a counter register in order to count an event or to generate a time delay. Okay, so this counter register is used to count a certain event or to generate the timer delay. In AVR ATmega 32, this counter register is known as Tcnt. Okay, so this one here is known as a Tcnt. Okay, this counter register is known as Tcnt. As I mentioned earlier, okay, this counter register can count an event. Okay, either you can use it as a count an event, or you can use this to generate a time delay. Okay, to count an event, okay, you need to connect the external event source to the clock pin of the register. Means that you need to connect the clock pin of the register to the external event source. Okay, usually we connect to switches lah. Okay, so whenever an event occurs externally, the content of the counter is incremented. Okay, whenever the switch is pressed, for example, okay, the value of this counter register will be incremented. Okay, and then to generate a time delays, okay, you are going to connect the oscillator to the clock pin of your counter. Means that you need to connect your counter register, your Tcnt, to your oscillator. Okay, so whenever the oscillator ticks, the content of the counter will be incremented. Okay, so this is how you're going to use the counter register in order to count an event or to generate the time delay. Okay, so this is the general overview of your counter and timer in microcontroller. You have a counter register, which is, okay, this counter register known as a Tcnt, and then we have a flags. Okay, whenever the counter is the timer is set, whenever the timer the delay that you're going to generate is complete, then the flag here will be set. Okay, so then you have a multiplexer here. Okay, so this multiplexer here will be determined lah. Either you're going to do to count an event ataupun to generate a time delay. Okay, if you connect this counter register with oscillator, means that you're going to generate the delay. If you connect this counter register to your external source, okay, to the switches, then what happens is you're going to make this counter register to count a certain event. Okay, so the content of counter register represent how many ticks have occurred from the time we have cleared the counter. Okay, those to generate a time delay. Okay, in order to use the counter register to generate a time delay, there are two methods. Okay, the first one we call it as a compare mesh. The second one we call it as a overflow method. Okay, let's look at the first method, which is by using a compare mesh. Okay, what you're going to do is when you use the compare mesh, okay, you need to clear the counter at the start time and wait until the counter reach a certain number. Okay, so means that the Tcnt value, you should be set it as a 0 at the beginning, and then after that, okay, you set your Tcnt with 0, and then you have the what we call here then you set your another register, okay, which is we call it as a Ocr register, which is this register here. Whenever this register, contohlah, if you put this one is 10, whenever the Tcnt equal to 10, then means that you already generate the time delay. Okay, which is, okay, the start time and wait until the counter reach a certain number. This number that you're going to set to your OCR. Okay, for example here, a micro peak speed is 1 megahertz and the content of the counter register is increment 1 per microsecond. Thus, if you're going to make a time delay of 100 microseconds, what you're going to do is we should clear the counter and wait until it becomes hundreds. Okay, so when it becomes hundreds, what happens here? You already generate 100 microseconds. So in the micro P, okay, there is a flag for each of the counters. Okay, kalau kamu use the CTC method, okay, the first method, we need to look at the OCF flags. Okay, if you're going to use the overflow, we're going to see at the TOV flags. Okay, later we will see more detail on these flags here, the OCF flag, the TOV flag, the OCR, what the OCR do, and what the Tcnt do. Okay, for the second method here, okay, to generate a time delay, okay, we use the overflow method. Okay, the second is overflow method. Okay, so this overflow method load the counter register and wait until the counter overflow and the flag is set. Okay, so you load your Tcnt value. So let's like Tcnt value, you load it something like this, and then you need to wait lah until okay this Tcnt overflow from the value is overflow from Tcnt. Then you already generate your delay. Okay, later we will see more detail how the CTC mode works and how the overflow mode works. Okay, for example here, a micro P speed is 1 megahertz. Okay, with an 8-bit counter register. If you're going to make a delay of 3 microseconds, okay, then what you're going to do is you need to load your counter register, which is your Tcnt with FD. Okay, and then wait until the flag is set after 3 ticks. Kenapa 3 ticks? Because after the 3 ticks, you already generate 3 microseconds. Okay, so the first ticks, the content is incremented to FE, and then the second ticks, the content increment to FF, while for the third tick, the content will be overflow from your Tcnt, okay, which is from FF, and then the content will become 0. Why FF? Because the counter register in ATmega32 only 8 bit, so the maximum number is FF ataupun 255. Okay, so when this value here is incremented, then it will become 0, 0 lah. And when 0, 0, then the overflow occurs and the flag is set. Okay, so this is the how to generate a delay by using the overflow methods. Okay, next we are going to see the programming by using timer 0, 1, and 2. Okay, so let's look at the instruction first. So every timer needs a clock pulse to tick. Okay, the clock source can be internal or external. Okay, the internal clock source is coming from the frequency of oscillator. Okay, your oscillator or Xtel, sometimes we call it as a Xtel or microprocessor speed. Okay, so oscillator Xtel is same thing. Okay, is fed into the timer as a time delay generation. Okay, so this is the internal clock source. While the external clock source, the feed pulse through one of the AVR pin as a counter. Okay, so you have 2 clock pulse. One is internal, which is by using the oscillator, and the other one by using the external clock source. Okay, now we are going to focus on this one, the internal clock source, because we're going to generate, in order to generate a delay, we're going to use the internal clock source. If you're going to generate a counter, then you need to focus on the external clock source. So in ATmega32, there are 3 timer. Okay, kita ada 3 timer, which is timer 0, timer 1, and timer 2. Okay, so timer 0 and timer 1, timer 0 and timer 2 is 8-bit size, while timer 1 is 16-bit size. Okay, so this timer can be used as a timer to generate a time delay or a counter to count event happening outside the micro-P. Okay, so you need to remember you have 3 timers in Amiga 32, which is timer 0 and timer 2. The size is 8-bit, while timer 1, the size is 16-bit. Okay, next, we are going to see what are the basic registers of timer that you need to familiar with. Okay, so in Amiga 32, there are total of 4 basic registers that are associated with timer. Okay, this is a 4 basic register that you need to know lah. Okay, the first one here, we call it as a Tcnt. Okay, so this is your timer ataupun counter register. Okay, the Tcnt is your counter register. And then we have a Tccr. Okay, the end here, you can replace it with a 0, 1, or 2. Okay, so if 0 means that you're going to use a timer 0. If 1, you're going to use a timer 1. If you replace it with Tccr2 means that you're going to use timer 2. So this Tccr is used to control as a counter control register, means that you're going to do setting. Okay, whenever the setting you need to do inside of your Tccr. Okay, and then you have the Ocr, which is the output compare register. So if you're using this CTC mode, then you need to use this Ocr register. Okay, to compare the output of your Tcnt with this Ocr register. Okay, when the value is equal, then what happens is you already generate the delay. Okay, last but not least, if your flex register lah, known as a Tifr. Okay, so inside of this flex register, you will have the TOV, which is using for the overflow flag, and then OCF used for the CTC flag ataupun output compare flags. Okay, so all of the flags, okay, either you use a overflow method or CTC method will be stored inside of this Tifr. Okay, so let's look more detail on what this register do. Okay, so first we look at the Tcnt. Okay, the Tcnt register is actually your counter register. As I mentioned earlier, the Tcnt is your counter register. So upon reset, this Tcnt contains 0. Okay, whenever you reset, the value of your Tcnt is 0. So this Tcnt will count up with each pass. Okay, so the value inside of this Tcnt will be incremented. Okay, depending on the clock path that you are going to use. Either it's an internal clock source or external clock source. Okay, if you're going the internal clock source, so every ticks or every millisecond, okay, the value of your Tcnt will be incremented. If you're going to use the external clock source, means that every time you press a switch, then the counter, your Tcnt value will be increased. Okay, so the content of the timer or counter can be accessed by loading a value to Tcnt or read its value. Okay, then next, we have the Tccr register. Okay, so Tccr register is used for setting mode operation. Okay, so whenever your setting, you need to do inside of this Tccr register lah. Okay, for example, if you're going to use the overflow method, so you need to set inside of this Tccr. If you're going to use a prescaler, then you need to set it inside of this Tccr as well. Okay, and then we have the Tifr. Okay, so the Tifr will consist of TOV flag and OCF flags. Okay, so the TOV and flags will be set whenever the timer overflow, and the OCF flag is set whenever the compare mesh is equal. Okay, then you will have the OCR register. So this OCR register is used to compare the content of OCR with the content of Tcnt. Okay, when the OCR equal to Tcnt, then the OCF flag will be set. So this timer register actually located inside of your I/O memory. Okay, those you can read or write by using in and out instruction. If you're going to use assembly language, we can use the in and out to read and write this register here. Okay, so this is your timer in ATmega32. If you can see here, you have a timer 0, timer 2, which is the size here is 8-bit. Okay, you see here the Tcnt 8-bit wide, OCR also 8-bit wide. If you're going to use the what we call here overflow method, so that okay, we need to see the Tcnt value. Okay, whenever the Tcnt value is overflow, then the TOV flag will be set. If you use the CTC mode, then you need to compare Tcnt with OCR. Whenever the Tcnt equal to OCR, then the OCF flag will be set. Okay, sama jugalah for the timer 2. This one also 8-bit size. Okay, so the TCCR used for the setting. Okay, and then if you're going to use the what we call here overflow method, whenever the Tcnt is overflow, then the TOV2 will be set. If you're going to use the CTC method, then you need to compare between the value inside of your Tcnt with the value inside of OCR. If the value is equal, then the OCF2 will be set. Okay, meanwhile for the timer 1, okay, so this one is 16-bit timer. Okay, 16-bit. So that's why you see here the TCCR also 60-bit. You see, TCCR 1A, TCCR 1B, 16-bit. The Tcnt also 16-bit, OCR 1A and OCR 1B also 16-bit. Okay, if you're going to use overflow, then the TOV flag will be set lah. If you're going to use a comparator, the CTC mode, then you need to compare lah. Either you're going to use the OCR 1A or to compare with OCR 1B. Okay, if you compare with OCR 1B, what happened here? The OCF 1A flag will be high whenever the Tcnt value equal to OCR value. If you're going to use the what we call here OCR 1B, then whenever the Tcnt equal to OCR 1B value, then the OCF 1B will be set. Okay, so now we are going to learn about how to program using how to program your timer by using C programming. Any question up until here? Ada soalan tak? Any question? Okay, if no question, then we go to the timer 0 programming in C. Okay, before that, okay, before we going to more doing the before we going to learn about the programming, so I need you to familiar what is the CTC mode and what is the overflow mode. Okay, so this is your timer. Okay, so timer can be divided into two modes. Okay, two methods. One we call it as overflow, ataupun sometimes it called as a normal mode. And the second one here called as a compare mesh. Or sometimes sometimes we use a CTC mode. Okay, so this is a different name mah. Okay, so overflow. How to generate a time delay by using a overflow or normal mode. So let's lah. Okay, you have a water bottle. Okay, you have a water bottle. Okay, the size of this water bottle is 1 liter. Okay, 1000 milliliter. Okay, so this water bottle here, okay, actually your Tcnt. Let's lah. Okay, you're going to generate 5 second. Sorry, 5 millisecond. 5 millisecond delay. Okay, delay you're going to generate is 5 millisecond. Okay, so what happened here is, okay, by using the overflow, let's lah. Okay, every time you put a water inside of this, okay, so this is water. Okay, every time you put the water inside of this bottle here, okay, whenever the water reach 100 milliliter, okay, the time taken equal to 1 second. 1 millisecond, sorry, 1 ms. So, in this case here, okay, because you're going to use the overflow method. So, in order to use the overflow method, okay, the timer will be generated after the water overflow from this water bottle. So, how are you going to do that? Okay, first thing first, what you're going to do is, okay, to generate a 5 millisecond dose, you need to set your water so that, okay, the level of the initial water is at 500 milliliter. Okay, 500 ml. Okay, then after that, you put the water. Okay, once you set your Tcnt with 500 millisecond, then you put your water, and then this water here, okay, will reach 600 ml. Okay, so this is 1 second. You already generate 1 second, and then you go to 700 ml. So this is another 1 second. 800, 1 second. Okay, and then 900. This is another 1 second, and then 1000. Okay, so this is 1 second. Then after you put another water, so what happens is the water will start overflow from this bottle. So what happened? The TOV flag will be set. Okay. So once the water overflow from this bottle here, the TOV flag will be set. So the CPU know that you already generate the delay. So how many delay that you already generated? 5 millisecond. Not 5 seconds, 5 milliseconds. Okay, because every 100 milliliter is equal to 1 millisecond. So after this water is overflow from this bottle here, so you already generate 5 millisecond delay. Okay, for the compare mesh, okay, so again you have a bottle. Okay, this bottle here is your Tcnt. Okay, so the size of this water is 100 millisecond, 100 milliliter lah. Okay, you're going to generate a delay of 5 milliseconds, and the water flow here, the flow rate of your water is 100 milliliter per millisecond. Okay, for the compare mesh, what you're going to do is, okay, we need to compare with Tcnt, need to compare dengan OCR. Okay, so in order to generate a 5 millisecond, okay, you need to set your OCR so that it point to this 500 milliliters. So you set your OCR. So this is your OCR. So you set your water level so that Whenever the water level reach 500 milliseconds, then you already generate the delay. So this is the delay. This is the delay generated dekat atas ni. Okay, for the compare mesh, so what you're going to do is first you need to empty your Tcnt. Okay, make your Tcnt, the water bottle, empty. Okay, make the Tcnt 0. And then you put the water inside of this bottle. So the water level will increase. Okay, this is 100 milliliter, 200, 300, 400, and 500. When the Tcnt equal to 500, which is equal to the water level that you set earlier inside of your OCR. So what happened here? The OCR flag will be set. Okay, when the OCR flag will be set, so the CPU know that you already reached you already produced the delay. Okay, then you need to calculate lah. So this is 1 millisecond, 1 millisecond, 1 millisecond, 1 millisecond, and 1 millisecond. So you already generate a 5 millisecond delay. So this is the delay. Okay, this is for the compare mesh, and this is for the overflow. Okay, that is the two different different method lah. The first one by using the overflow method or normal mode, we call it as a normal mode, and the second one by using the compare mesh, or sometimes we call it as a CTC mode. Okay, any question? Okay, if no question, then we go to how to write the timer 0 programming by using C language. Okay, so here, okay, so this first we look at the Tcnt 0 register. Okay, because this is your counter register. Okay, the timer 0 is 8-bit in Omega 32. Thus, your Tcnt 0 is 8-bit wide also. Okay, so this is your Tcnt 0. The size of your Tcnt 0 is 8-bit. Okay, so this Tcnt, okay, can reach up to FF if you use hexadecimal, ataupun 255 if you use a decimal value. Okay, because it is a 8-bit. Okay, this is for the Tcnt 0. Next, we are going to see the timer setting, how to make a timer setting inside our Tccr 0 register. So the Tccr 0 is an 8-bit register used for control your timer 0. So whenever you're setting, you need to put inside of it this Tccr 0. Okay, so I'm going to highlight which bit that you need to focus. Okay, the first one here is WGM00 and WGM01, which is at bit 6 and bit 3. Okay, so this WGM00 and WGM01, which is your bit 6 and bit 3, will determine, okay, the timer mode that you're going to use. Okay, the first here is normal mode. Okay, if you put 0000 here means that you're going to use the normal mode, which is overflow method. And when you put 01, then you are going to use the CTC mode or compare mesh. Okay, so in this timer programming, we only focus on this normal mode and CTC. PWM and fast PWM, no need to. This one we will discuss this one. Okay, we only focus on normal mode and CTC. Okay, next. Then another bits that you need to focus or you need to familiar is these 3 bits here: bit 0, bit 1, and bit 2. Okay, this one. Okay, if you put 0000, okay, at this bit, what happens here? No clock source means that you're going to stop your timer. Okay, so to stop timer, you put 000 at this last 3 bit. Next, 001. So this is no prescaling. 010, okay, with a prescale of 8. 011, you're going to use prescale 64. 100, 256 prescaler. 101, you're going to use 1024 prescaler. Okay, so this is the prescaler setting. And this is without prescale. And if you put 110 and 111, so you're going to use the external clock source on T0 pin. So this one, if you're going to make it as a counter. Okay. If you're going to make it as a timer, so we only focus on this value saja. Okay, if you're going to make it as a counter, then you need to consider this value lah. Okay, so later we will go more detail what this prescaler do. Kenapa nak buat why we going to need the prescaler? Okay, so this is for the Tccr 0 register. Okay, so Tccr 0, first you're going to select the mode. Either you're going to use a overflow method ataupun Tcr method, and then the second one is the prescale setting. Okay, either you're going to use no prescale or with a prescale option. Okay, that is for the Tccr 0. Okay, so this is the summarize of what I said earlier. Okay, so let's look at the example. Okay, so find the value for the Tccr 0 if we want to program timer 0 in normal mode, no prescaler. Okay, use AVR crystal oscillator for the clock source. Okay, so you're going to make a timer 0, use a timer 0, normal mode, no prescaler. So what are the value that you're going to put? Okay, so here we're going to focus on this bit here. Okay, bit. Okay, for the Tccr, you're going to focus on bit 6. Okay, and bit 3. Okay, so this is your timer setting mode. And next, this is the prescale option. Okay, since you're going to use the overflow method, okay, so overflow, the value that you're going to put at bit 6, overflow, okay, the value that you're going to put at bit 6 is 0 and 0. Okay, so that's why we put 0, 0 kat sini. Why? Okay, no prescale. The value that you're going to put is 0, 0, 1, according to this table here. Okay, 0, 0, 1, no prescale. So this is the value that you're going to put to your Tccr 0. So how to write in the C programming? Okay, so you just simply write Tccr 0 equal to 0B 0, 0, 0, 0 and 0, 0, 0, 1. Okay, this is a normal mode ataupun overflow mode, and then without a prescale. Okay, so this is the value that you're going to write in the C programming. Okay, another example. Okay, find the timer clock frequency and its period for a various AVR based system with the following crystal frequency. So assume that no prescaler is used. Okay, so we are going without prescaler is used. Okay, so now you're going to find out what is your period. Okay, based on this crystal frequency. Okay, so you know that the period, okay, the equation for period is T equal to 1 over F. Okay, F is your frequency, okay, your crystal frequency. Okay, so for the 10 megahertz, the period is T equal to 1 over 10 megahertz, then you will get 0.1 microseconds. Okay, this is without a prescaler is used. If the prescaler is used, then you need to find out lah then you need to find out the new F, okay, F yang baru, and then after that, from that F, new F, then you're going to find your T. Okay, B 8 megahertz. So the T for 8 megahertz is T1 over 8 megahertz, then you get 0.125 microseconds. Okay, for the frequency of 1 megahertz, then the period is 1 over 1 megahertz, you get 1 microsecond. So this is how to calculate the period. Okay, next, the Tifr register. Okay, so the Tifr, which is a timer counter interrupt flag register, contain the flag of different timers. So this is your Tifr. Okay, you have a T bit 0 for TOV0. Okay, so this is for overflow. This is the flag for overflow method for timer 0. And then this is the flag for OCF0, means that this is the flag for CTC mode for timer 0. Okay, whenever the flag is 1, means that the timer 0 has overflow. Okay, if the OCF0 is 1, then the compare mesh is occur. Okay, so this one is for timer 0. Okay, then this one here, timer 1. Okay, you have a TOV1 flag, OCF1B flag, and OCF1A flag. This is for the overflow method, and this is for compare mesh. And then next is this 2-bit here, TOV2 and OCF2. So this is for the timer 2. Okay, so the TOV0, which is the timer 0 overflow, the flag is set whenever the counter overflow, i.e. going from FF to 00. Okay, whenever the overflow occurs, then the the TOV0 will be set. Okay, so when the time roll over from FF to 00, TOV0 flag is set to 1, and it remains set until the software clear it. Means that you need to reprogram in order to clear the value. Okay, so this is the normal mode as I mentioned earlier. So in normal mode, the content of the timer or counter increment with each clock. So it will count up until it reach its max of FF. Okay, so when it roll over from FF to 00, it set high to TOV0. Okay, so this is your Tcnt, and this is your maximum of your Tcnt. Okay, so whenever your Tcnt, okay, because overflow from FF to 00 to 0, then what happen? The TOV flag can set. Okay, so this one here, the TOV flag can set. Okay, so this is for the normal mode. Okay, now we're going to look at what are the steps in order to program the timer 0 using normal mode. Okay, so this is the step that you're going to remember. Okay, I just use this one here. Okay, I just put here down here. Okay, so normal mode. Okay, so step number 1. Okay, you need to load your Tcnt value. Okay, so how to load the Tcnt value? By doing calculation. Okay, you have a equation for that. Okay, so for the normal mode, the equation that you're going to what we call here, remember is, okay, first, this is the equation. First, T equal to 1 over F, which is you need to find out what are your period. Period equal to 1 over F. Then after you get the period, second, calculate the delay. Okay, by using the delay equal to period multiply with your count. Okay, so this is the second equation that you need to remember. Delay equal to period multiplied by count. And the third here is Tcnt equal to FF, okay, which is your maximum value of your Tcnt minus count plus with 1. Okay, so this is the formula that you need to remember. Okay, you already know your frequency. Okay, then from that frequency you can get the T. Okay, and then you know that what are the delay that you're going to generate from the T that you calculated. You can get your count from the delay that you're going to generate, and then after you get this count here, then you can find out what are the Tcnt value. So this Tcnt value you will load to your Tcnt. Okay, so this is the first step. Load the Tcnt. How to load the Tcnt? By using this equation here. Okay, and then the second step. Okay, you're going to set your Tccr. Okay, so in this Tccr, you have two settings. One is mode. Either you're going to use a normal mode ataupun CTC mode, and then prescale. Okay, and then remember back lah. Okay, so this is your Tcnt. Okay, so bit 6 and bit 3 will determine your mode. If you put 0, 0, then it is normal. If you put 0, 1, then what happen here? This is a CTC. Okay, then this bit here, the last 3 bit here. Okay, so this is your prescale. If you put 0, 0, 0, means that you're going to stop timer. 0, 0, 1, no prescale. And 0, 1, 0, so this is your prescale with 8. And then sampailah 1, 0, 1, which is 1, 0, 2, 4 prescaler. Okay, so if you're going, how Okay, if you're going to use the timer 1, then you need to use the Tcnt 1 lah. If you're going to use the timer 0, then you need to use the Tcnt 0. It depends on the timer that you're going to use. Yes, all three timer can use normal mode, and all three timer also can use CTC mode. The CTC mode. But the setting for timer 1 is different from timer 0 and timer 2. Okay, because the timer 1, the size of the timer is 16 bits, so the setting is quite different. Okay. And then number 3. Okay, step number 3, monitor. Okay, when you done the setting, then you need to monitor your TOV flags. Okay, once your TOV equal to 1, okay, so kat sini, if TOV sama dengan kosong, okay, you keep monitor, which is the Tcnt will keep increase. If the TOV equal to 1, what happen here is you exit monitoring loops. Okay, you exit the loops. Okay, once the TOV equal to 1, so the step number 4, what you're going to do is, okay, you need to stop timer. Okay, how to stop timer? Okay, by writing down Tccr. Okay, tak kisahlah Tcr 0 ke 1 ke 2. Okay, with 0x00. Okay, why? Because you see, if you put 00 at this prescale here, what happens? The timer will be stopped. Okay, this is for the timer 0 lah. Okay, so Tccr 0 sama dengan O at 00, so the timer will be stopped. Okay, and then step number 5. Okay, clear your TOV. Why you're going to clear your TOV? Because, okay, after exit the loop, the TOV is set. Then to use the timer again, then you need to clear your TOV so that your TOV become 0. And step number 6, okay, repeat number 1. Okay, so you need to go to step number 1. Load the Tcnt, set the Tccr, monitor your TOV, stop timer, clear TOV, and repeat again. Okay, so this is how this is the step that you need to follow in order to program your timer 0 by using normal mode. Okay, so let's look at the example here. Okay, kita tengok example dulu. So in the following program, okay, we are creating a square wave of 50% duty cycles. Okay, you're going to create a 50% duty cycle with equal portion high and low on port B pin number 5. Okay, timer 0 is used to generate the time delay. Okay, you're going to analyze the program. Okay, so you have this what we call here program here, so you need to analyze the program. Okay, so first you include this file here, AVR macam biasalah, include this file, and then this is, okay, you initialize your timer 0 delay function. Okay, so this is a TO delay function, so you initialize this one, okay, and then followed by your main program. Okay, so inside of your main program, since this one here, if you can see this example here, you're going to create a square wave. Dekat mana? Port B pin number 5. So that's why port B pin number 5, you need to make it as a output port. Okay, so make your PB5 as output port by using by putting DDRB equal to shift 1 to the location to the left 5 times. Okay, so PB5 will make it as a output, and then port B equal to 0. So means that you're going to clear your port B. Okay, so while 1, okay, port B equal to port B, and then exclusive OR with, okay, shift 1 to the left 5 times, means that you're going to toggle PB5. So what happened here? Okay, so this is your AVR. This is your PB5. Okay, so this PB5 here, you make it as an output, which is you're going to generate a square wave. Okay, the square wave here, dia bagi tahu kat sini, the duty cycle of this square wave is 50%. Means that the size of logic low and logic high is equal lah. So this is 55% and this is 50%, sorry. 50% and this is a 50%. Okay. So based on this one here, you see here, okay, port B equal to port B, and then exclusive OR with this value. So then you call a delay. So this delay. So now the question is, what are the value of this delay? Okay, the what we call here, what are the delay that you generate in order to make this square wave? Okay, so this is the delay punya calculation programming. Okay, Tcnt 0 equal to Ax F2. So this is your first step, which is you load your Tcnt with this value, and then this is your second step earlier that I said earlier, TCCRO equal to OX01. Okay, so TCCR0 sama dengan kosong and 0001. Okay, so now you can identify lah. Okay, you know that what are the mode that this program is used. Okay, so it is bit kosong, bit 6 and bit 3. So bit 6 and bit 3 is 00, so you know that it use a normal mode. And then at the prescale kat sini, okay, the value is 001, means that no prescale. Okay, from this setting here, you know that this timer 0 use a normal mode with no prescale. And then while Tifr end with OX01 equal to 0, so this is how you're going to monitor your TOV flags. Okay, TOV0. Kenapa saya kata TOV0? Because of this value here. Okay, Tifr end with OX01. Kalau kamu tengok, OX01 actually is 0000, 0001, and you're going to compare it with your Tifr. Okay, so this bit here actually is your TOV0. While, okay, how saying that while Tifr not equal to OX01, I think this one also can. If you change with this one also can. Okay, selagi dia tak equal, it will keep monitoring. If it equal to with 1, then what happen here? Dia akan exit from the loop. Okay, so this one here, since this value is equal to 0, means that you need to keep monitoring lah. Unless the Tifr, okay, when the Tifr, the value is 000000001, which is you end this one here, you will get the hasil is 0000001, 0001. When you end this value, okay, so this is your TIFR, and this is the value. When you end this value, this is no longer equal to 0, then what happens? It will exit from this monitoring loops. Okay, so this is step number 3. After it exit, what happens? You need to stop your delay, stop your timer, and then number 5, this is how you're going to clear your TOV flags. Okay, to clear your TOV0 flags, you need to put 1. Okay, never put 0. Okay, this is the special what we call syntax lah, in order to clear the flags. Okay, by using a C programming, to clear a flag, we need to put 1. Okay, because in the C programming, we doesn't have the CLI, for example. Okay, in the timer programming, we have the CLI, SEI, right? But in this one here, in the timer programming, we doesn't have this one to clear and set the flag. Okay, so that's why we need to put 1 to the location that you're going to clear. Okay, so the question here is, okay, so this is the what happened lah. Okay, so in the above program, okay, you notice that you load the Tcnt with F2, okay, and then the Tccr0 is loaded and timer 0 is started. Okay, when you put this one here, okay, when you execute line number 2, what happened? The timer already started. Okay, it will start counting. Okay, so this timer 0 will come out and then pasti each o'clock. Okay, so what happened here? Okay, first you load the Tcnt with F2. So what happened? The TOV still kosong lagi. And when the Tcnt increase to F3, the TOV flag still kosong. Okay, so you will keep monitoring. And when Tcnt increase to F4, the TOV flag still 0. And then you need to keep monitoring, which is you still do this step number 3. Okay, when the TOV now is the Tcnt now equal to FF, the TOV masih lagi kosong. And then when this value here, the Tcnt roll over from FF to 0, 0, then what happen? The TOV equal to 1. So when the TOV equal to 1, then after that, what the CPU do is the CPU will execute step number 4, which is you need to stop your timer, and then after that, you clear the timer, okay, by put 1 to the location of the flag that you're going to clear. Okay, and now we are going to see the example here. All right, in example 9.3 earlier, okay, you're going to calculate the amount of time delay generated by the timer. Assume that the X-start is 8 megahertz. Okay, so now you're going to calculate what are the delay generated from this program here. Okay, assume that you use the clock frequency of 8 megahertz. So now you're going to find what are the delay. Okay, X-start is 8 megahertz. And then previously your Tcnt 0 sama dengan F2. And Tccr 0, the setting of your Tccr is 0x01. Okay, so this one here, we know that this is a normal mode. Okay, and then with normal mode, no prescale. Okay, so based on this calculation here, calculation yang ada atas ni, okay, you can find out what is your T. T sama dengan 1/8 MHz because there is no prescale use, so you can directly divide it 1 over your F. So kamu akan dapat berapa ni dekat sini? Okay, so this one here. Okay, 1/8 kamu akan dapat 0.125 microsecond. Okay, so this is your T. Okay, now you're going to find what is your delay. Okay, you don't know what is your delay. T you know. Okay, this now you're going to use the persamaan nombor 2. Okay, delay equal to T multiply with count. Okay, T you know is 0.125 microsecond. Now you're going to find what is your count. Okay, count kita tak tahu. How to get a count? From the persamaan 3, which is Tcnt sama dengan FF minus count plus 1. You already know that your Tcnt is F2. So from this formula here, F2 sama dengan FF minus with count plus 1, then count equal to FF minus with F2 plus 1. So what is your count? FF minus F2. So kamu akan dapat can you press the calculator? FF minus F2 plus with 1. Is it 13 or 14? Okay, you will get 14. Okay, 14 ya. Okay, FF minus F2 plus 1, supposedly you will get OE. Is it OE? A, B, C, D, E. Yeah. And then which is equivalent to 14. Okay, so now from here, you can masukkan dalam this persamaan. So 0.125 microsecond. Okay, multiply your count. So this is a 14 times. Okay, multiply with 14, then you will get 1.7 microseconds. Okay, so this 1.7 microsecond is actually, okay, this one yeah. Okay, the duration of this square wave. Okay, you have this square wave here. Sorry. Pen. Okay, so this is one. Where is my pen? This for 1.75 microsecond. So this one also 1.75 microseconds. So means that for the logic, the duration of logic low here is 1.75 microsecond, and this one also 1.75 microseconds. Yes, because this one here, okay, in this example, it doesn't specify the delay duration, but from here, okay, in this example here, it asks you to calculate the delay generated if the ether is 8 megahertz. Okay, from this programming, you're going to find out what are your delay. Okay, given that your external is 8 megahertz. So, okay, from here, you know that you can use the formula that I give you earlier, which is to get a period, you can use the 1 over f. And then once you get the period, and then you can use the delay equal to T multiplied with count. Okay, since you know your Tcnt value kat sini, okay, you can get your count. No. The initial value of the Tcnt is not set by your own. Okay, because this example here it already be given. Okay, based on this given programming, you need to find out what are the delay. But in your case, you are using the delay. So then what you're going to do is you need to find out what are the Tcnt value. Okay, so let's look at another example. Okay, so this is how to find the value to be loaded in the timer. Okay, so this is the summarize of this equation here. Okay, as long as you remember this question, then you'll be okay lah. Okay, so this is the summarize of the what we call the equation. Okay, so now we go to this example. Okay, so assume that the external is 8 megahertz. Okay, given the speed, okay, your clock frequency is 8 megahertz. And then you are going to write a program to generate a square wave with a period of 12.5 microsecond on. Sorry. Okay, so I take this one and bring it to sorry. Okay. Okay, given that external is 8 megahertz, okay, kamu tahu the external is 8 megahertz. Okay, you're going to write a program to generate a square wave with a period of 12.5 microsecond. Okay, so square wave with a period of 12.5 microsecond on port B pin number 3. Okay, so you have this your microprocessor. Okay, this your PB3. This PB3 will produce a square wave, and it says that this period of the square wave is 12.5 microseconds. So what are the delay that you're going to generate? Based on this information, what are the delay that you're going to generate? Because you're going to write down your program. Okay, to write down the program to generate a square wave. Okay, based on this information, guys, can you tell me what is the delay that you're going to generate? Siapa boleh bagi tahu? Okay, Josh saying that 6.25 microsecond. Why? Why should you say that? It's 6.25 microsecond. Why? Kenapa 6.25 microsecond? Okay, so you know that. Okay, this information here, period of 12.5 microsecond means that this one here is the period of your square wave, 12.5 microsecond. Okay, to generate a delay, we're going to generate a delay for either this one or higher logic and low logic here. Okay, so 12.5 microsecond you divided by 2, so the delay that you're going to generate is 6.25 microseconds. Okay, because this is a 50% duty cycle. So we assume that the logic high and logic low have a same portion of delay. Delay dia sama, which is 6.25 microseconds. Okay, so that's why we're going to generate a 6.25 microsecond delay. Okay, so what are we going to do? Okay, so T, we use the first equation, T equal to 1 over F. Okay, so assume that, okay, kita assume lah, this one here, no prescale is used. Okay, use a timer 0, no prescale, and normal mode. Okay, so T sama dengan 1 over F, which is 1 over the frequency here is 8 megahertz. So you will get 0.125 microseconds. Okay, so this is your T. Okay, next, once you, this is the persamaan 1, and then use the persamaan 2, which is delay equal to T multiplied by count. Okay, you know that your delay that you're going to generate is 6.25 microsecond. And the T here is 0.125 microsecond. Now you're going to find out what are your count. Okay, so count equal to 6.25 microsecond divided with 0.125 microsecond, then you will get berapa kat sini? 50 times. Okay, then after that, from there, you use the persamaan nombor 3, the equation number 3, which is Tcnt 0, okay, is equal to FF minus count plus 1, which is 255 minus 50 tambah dengan 1, and then you will get berapa kat tu? 206, which is equivalent, if you convert to hexadecimal, you will get 6 CE. Okay, once you obtain the Tcnt, then after that you can do the program lah. Okay, so now you're going to write down the program. Okay, this program to generate a square wave. Okay, so firstly first, apakah kita nak kena tulis? Okay, first hashtag include avr/io.h, and then you define your delay function. Okay, so void, contohlah delay ni 6.25. Okay, delay timer 0 void. Okay, so initialize your ataupun define your delay. Okay, because we're going to make a delay function after this. All right, and then we start with our main program, int main void. So inside of this int main void, so what you're going to do inside of this int main void? Okay, you need to initialize lah. Okay, initialize your port B, pin number 3, so that it will become an output port. Why? Because you're going to produce the square wave kat situ. Okay, so DDRB equal to OXFF. Okay, just make all the port B as a output also can. Okay, make port B sama dengan output. Okay, and then port B just as equal to 0. Okay, letaklah port B equal to 0 so that the first value that you're going to create is 0. And then after that, while 1. Okay, which is you're going to generate this square wave forever. Okay, continuously. Okay, so port B equal to port B and then exclusive OR with 0B 000. Sorry. 001 00000. Okay, this is your PB5 or PB3 just now? PB3. Okay, sorry. PB3, not PB5. Salah. Oh, I need to padam yang ni. Padam the whole thing. Okay, 0B 0000 and then 1000. So this is your PB3. Okay, you're going to toggle your PB3. And then after that, okay, call this delay here. So make sure the name is correct. Delay T0 and close curly bracket. Okay, so now we're going to write down our delay punya subroutine or delay function. Okay, which is delay, sorry, not this one, void delay. Okay, open curly bracket and close curly bracket. Okay, so now what are the first step that we're going to do? To write down our delay programming. Okay, so Tcnt0 equal to OXCE. Okay, based on the value that you calculate here. Okay, this is the first step. Second step, after you load the Tcnt0 value, then you need to do the setting lah. Tccr0 setting. Okay, so what is the setting that you're going to put is 0B 000001. Okay, which is normal mode. Okay, and then no prescale. Okay, you can use the binary representation or you can use the hexa representation. If hexa, Tccr0 sama dengan 0B, 0x01. Okay, step number 3. Okay, so this step number 3, okay, you just write down y Tifr and then anyone? Siapa nak tolong? Okay, while Tifr end with Mana tadi kita? Where are we? Okay, here. Okay, TIFR and with okay 0x01. Okay, is it equal to 0? If yes, it will keep repeating. If not, if the TOV 0, this is monitor TOV 0. Okay, if the TOV 0 equal to 1, then what happens? Step number 4, stop timer. Okay, how to stop timer? By put 0 to your Tccr. Okay, so this is stop timer. Okay, and then step number 5, then you need to clear the TOV 0 flags. How to clear the TOV flag? By putting TIFR sama dengan okay, letak satu which is 0x01. Okay, sometime, okay, you will see this step here, TIFR equal to TIFR or with pun boleh juga. Okay, so this one also, this step number 3 also you can replace with this one. Chua Xinglong, yes, the timer will count immediately after you execute this line here. Okay, the timer will start count. Okay, so this one, if you're going to change this one also, you can use something like this. Step number 3, boleh juga kamu tulis Y. Okay, this is the fancy way lah. TIFR and with TOV0 is it sama dengan kosong. Okay, so this is how to write the program for by using timer 0 normal mode without prescale. Any question? Okay, actually, okay, this the last 3 steps here you can memorize. Okay, only tukar the flag that you're going to use. The rest is similar. Okay, this last 3 steps you can memorize this instruction here. Only change dekat sini je. Okay, of course lah yang di atas ni depending on your setting lah. Depending on your setting and then as well as your Tcnt value. Okay, co-children, why did we clear TOV by TIFR equal to OX01? Okay, because this is what we call here. Okay, I also cannot answer this one because this one, okay, this is the special lah. To clear a certain flag, okay, by using a C programming, we need to put 1, not to put 0. Okay, that is the rules. Okay, to clear the flag inside of our status register or inside our what we call here Tifr register, we need to put 1. Okay, for the status register, of course lah, because we have the CLI and then we have a SEI. That's why it's okay lah. If you put SEI, you know that you're going to set your I equal to 1. And if you put the CLI, you're going to clear your I equal to 0. But TIFR, no such thing. Okay. But no such what we call here special instruction to clear and to set a certain this flags here. Okay, to make sure the timer really stop, we use this step number 4. This is how you're going to stop the timer. Okay, because if you see your TCCR 0 register, okay, to start a timer, mana tadi? Not this one. Okay, here, dekat sini ya. Okay, to stop the timer, you need to put 0, 0, 0, 0, 0, 0 dekat bit 0, 1, and 2. Okay, this is a timer or counter stop. This is how you're going to stop the timer. Okay, that's why we do the step number 4. To stop the timer, we just put 0 to our TCCR 0. Okay, any question? Any other question? If no question, then we go to... Okay, this one already done. Okay, we're going to see... Chua Xinglang asks, if we don't stop the timer, it won't affect our main program also, right? Okay, if you not stop the timer, yes, it will not affect your main program. But I'm afraid if you're not going to stop the timer, then what happens is, if you're going to not stop the timer, as long as you clear your flag, then you can use the timer again later. But to be safe, we just stop the timer. Okay, in step number 4. Okay, now we are going to see the prescaler and generating a large time delay. So previously we calculate the timer without a prescale option. Now we are going to generate a timer with a prescale option. Okay, so previously the size of the timer delay depend on 2 factors. Okay, one is the crystal frequency. Either you use the smallest, the lower speed or the higher speed, and the timer counter register size. Either it is 8-bit or 16-bit, in which the largest time delay only achieved by making your Tcnt 0 equal to 0. Okay, of course lah, for overflow method, in order to generate a large time delay, okay, you need to make sure that your Tcnt sama dengan kosong. Okay, so this is the delay that you can generate. If you put your Tcnt somewhere around here, so this is the delay that you can generate, which is smaller lah compared to this one. Okay, so this is your Tcnt. Let's say that you put at 200. Okay, only 55 clocks that you can generate. Okay, so the question here is, what if that is not enough? Okay, dia kata, what if the delay that you're going to generate is not enough? Tak cukup. Okay, you intended to generate a 500 millisecond delay, but by using this one here, even though you make it the largest delay, which is you put the Tcnt 0 with 0, but this one although can manage to generate 100 milliseconds, which is not enough. You're going to generate 500. So the answer is by using the prescale option in order to increase the delay by reducing the period. Okay, by reduce the period, we can increase our delay. Okay, because the T equal to 1 over F. Okay, so the prescaler option allows us to divide the instruction clock by factor of 8 to 100 to 1024. Okay, so this prescaler option, in order to use the prescaler option, so you need to find out what is your F new. So F new sama dengan F, okay, the initial F divided by your prescale. Okay, once you get the F new, then you need to calculate your new T. Okay, so this is how we the prescaler option is used in order to generate largest time delay. Okay, so previously with no prescaler enabled, the crystal oscillator frequency is directly fed into timer 0. Okay, so you directly use the timer 0, the whatever value from your crystal frequency, and use it in your equation. But now, if the prescaler bit is enabled, okay, you're going to divide the clock before it is fed to your timer 0. Okay, so the lower 3 bit in your Tccr 0 will give the option of the number we can divide. Either it is 8, 64, 256 or 1024. Okay, for example here, find the timer clock frequency and its period for various AVR-based systems with the following crystal frequency. Assume that a prescale of 64 is used. Okay, A, 8 megahertz. Okay, so 8 megahertz, what you're going to do is you need to divide it by 64 because you're using the 64 prescaler. Okay, so that's why 8 megahertz divided by 64, you will get a new F. Okay, new frequency, which is 125 kilohertz. Okay, then from this 125 kilohertz, then you need to find out what are the new T. Okay, T equal to 1 over 125 kilohertz, then you will get 8 microsecond. Okay, similar to this one here. 60 megahertz divided by 64, you will get 250 kilohertz. And then after that, you find the T, which is 1 over 250 kilohertz, you will get 4 microseconds. Okay, while C, okay, if your oscillator frequency is 10 megahertz, you use a prescale of 64, so 10 megahertz divided by 64 first, okay, you will get this frequency here. Okay, from this frequency, you will get your new T. Okay, so another example, find the value for Tccr0 if we want to program timer 0 in normal mode with a prescale of 64 using internal clock for the clock source. Okay, so you now okay, you're going to use a timer 0 normal mode with a prescale of 64. Okay, so again, recall back your Tccr0. So this is your Tccr0. Okay, bit 6 and bit 3, this belong to your mode setting. Okay, since you're going to use a normal mode, so you need to put 0, 0 kat situ. Okay, and then this is your prescale. Okay, so you're going to use a 64. So what are the value that you need to put here? Okay, according to this table, for the 64, the value that you need to put, mana tadi? Okay, 64, this is the value for the 64, which is 0, 1, 1, 1. Okay, so you put 0, 1, 1, 1. What about the rest? The rest, you just put 0. Okay, so this is how to write the program? Tccr0 equal to 0B0000001. So you know that it is a normal mode, and then with prescale 64. Okay, another example. Okay, assume that X is 8 megahertz. Okay, you're going to find the clock period fed into timer 0 if a prescale option 1024 is chosen. Okay, show what is the largest time delay we can get by using this prescaler option and timer 0. Okay, so first thing first, okay, we have 8 megahertz and you use a 1024 prescaler. So what you're going to do is you need to find what is your F new. So F new sama dengan 8 megahertz divided with 1024, you will get 7812.5 hertz. Okay, from here, then you need to find what is your T. T sama dengan 1 over F, which is 1 over 7812.5 hertz, then you will get 0.128 milliseconds. Okay, so now the question here asks you, show what is the largest time delay we can generate by using this prescaler option. Okay, you're going to find out what are the largest time delay. How to make the largest time delay if you are using the overflow method. Okay, to make a largest time delay by using overflow method, you need to make sure that your Tcnt value you set dekat berapa? Dekat kosong. Okay, so from persamaan nombor 3, equation number 3 is saying that Tcnt sama dengan 255 or FF minus count plus with 1. Okay, so since you put your Tcnt equal to 0, 0 sama dengan 255 minus count plus 1, then you get count, okay, sama dengan 256. Okay, so from here, you can calculate your delay, which is your delay sama dengan T minus multiply with count. Okay, so T, what is your T? 0.128 millisecond darab dengan 256. Okay, the largest delay that you can generate, okay, which is equal to 0.03278 seconds. Okay, let's say lah, if you're not going to use if you're not using the prescale option, okay, without prescale, okay, what are the largest delay that you can generate without a prescale? Siapa boleh tolong? Okay, without a prescale, T sama dengan 1 over 8 megahertz, which is sama dengan berapa ni? Anyone? Please press your calculator. Okay, 0.125 microseconds. Okay, to make a largest time delay, okay, you need to set your Tcnt sama dengan 0. Okay, which is you calculate the count is 256 time. Okay, so delay, the largest delay that you can generate is 0.125 microseconds multiply with 256, and then you will get, is it 12 point, berapa? 32 ya? Okay, 32 microsecond. Okay, compared to this one here, okay, by using a prescaler, okay, you can generate up to 30,768 microsecond. Okay, without prescaler, you can generate up to 32 microsecond only. But with a prescaler 1024, okay, you can generate up 30,768 microsecond, okay, which is equivalent to 32.768 millisecond. Okay, so that's why we're going to use the prescaler, okay, in order to increase our delay. Okay, I think we'll stop here. Okay, and then later we will continue with how to do the programming by using the prescale. Okay, any question up until here? Ada soalan tak?